Hello everyone, let's discuss problem number 18. We'll just highlight the main measurements given in the question. The first one will be 52 cm potentiometer wire. If the cell is shunted by a resistance of 5 ohm, shunt resistance 5 ohm. The balance is found when the cell is connected across 40 cm wire. Okay, we have to find the internal resistance. Now, to start off the question, we'll consider two cases. First, when the switch is open, and second, when the switch is closed. So, for the when switch is opened, E is equal to E is the potential. Potential is equal to lambda into L1, where lambda is the potential gradient, right? And L1 is the length of the wire. Okay, so E is equal to lambda L1 when the switch is open. Now we consider when the switch is closed. That is, in that case, we consider the internal resistance. So potential minus EIR is equal to lambda L2. That is the second equation, right? When we divide these two equations, we get a relation between these two. That is the equation we divided. Now we can say 1 minus IR upon E is equal to L2 upon L1, right? We know I is equal to potential upon resistance. So the total potential in the circuit was E, that is E, right? And total resistance circuit would be R plus R. So I can be replaced by E upon R plus R. Okay, so 1 minus R upon R plus R. E is cancelled on denominator and numerator is equal to L2 upon L1. Now we take LCM here, and the solution is R upon R plus R is equal to L2 upon L1. We cross multiply, right, and take find the resistance R. We need to find small r, right? We'll cross multiply and take the capital R on the other side, right? It would give us the equation R into L1 upon L2 minus 1. Now we simply have to put in the values. That is, R was equal to 5, L1 is equal to 52, L2 is equal to 40, right? So the equation answer becomes 1.5 ohm, the correct answer.